So next problem also little bit of lengthier problem I solved already. Consider the operator pi vector equal to p minus q a vector, where p is the momentum operator and a is vector potential. They are having three component: ax, ay, az is the vector potential, and q denotes the electric charge. If b is equal to bx, by, bz, the magnetic field components denotes the magnetic field. The z components of the vector operators pi cross pi is, they are asking what is the z component of the vector operator. So already we know any two vectors, suppose a cross b or same vector operating, if you want a ith component, that should be equal to Kronecker delta of ijk, the ith component of the vector is equal to aj bk. That means this indices ith, the first indices represents ith component. Einstein summation also will exist. Actually it will call the Einstein summation. So I j and k it will come. So aj bk, we are going to use this simple relation here. So pi cross pi I vector is equal to epsilon I j k. We ith component, if we need ith component, pi j pi k, but actually we need z component, so we can write pi cross pi z component of the vector is equal to epsilon x y z. So keep this indices without any change, then pi x pi y plus epsilon, the already I told the summation is exists, so interchange this yx, keep the component z pi y, because yx now pi y pi x. Already we know the permutation. If it is odd permutation, epsilon value, Levi-Civita value plus 1. Suppose odd permutation minus 1, even permutation plus 1. Here actually even permutations we are keeping plus. Here odd permutation we are keeping minus. Now come here, pi x is x component of pi x. Just if you are expanding the component wise, already I done erased it. So you will get the x component px minus qax, because our pi vector is nothing but p vector q a vector. So x component is nothing but px minus qx. Yth component of pi y is py minus qay. Same yth component here, x component. Then normal multiplication you can do with these two, with these two. If you are multiply, you will get 4 option, 1 2 3 4. Here also 4 will get. So already here minus is existing. Then multiply with minus inside, px py minus py px, because all of them are operator, this both of them will come out with each other, so equal to 0. That means you can make the, from out of these two, px comma py commutation, this commutation go to 0. Now come to the our second, pick up minus q px ay, here from here plus q py ax. Then another relation, minus q ax py from the first, from the second, minus into minus plus q ay px. Anyway, the last relation plus q ax ay minus q ay ax. These are the vector potential, not an actual operator, so it goes to 0. You can cancel these each other. Even if you are making the commutation between these two, obviously the same operator, the commutation goes to 0. Now come here, pick up that momentum operator stem operating on the vector potentials. So these two things are momentum operator, x operator operating on vector potential ay, y operator operating on x. I am taking first one, take the minus q outside, then you will get pxay minus of pyax. Now if I see the next time minus q pick up out, ax py minus ay px. So the next is, we know the momentum operator is minus I h cut dou by dou x, if it is x component. Y component same, py equal to minus I h cut dou by dou y. We are using that one, just px here minus I h cut dou by dou x. So it will give already minus is sitting outside plus dou by dou x ay minus dou by dou y ax. Then keep it this one. So we can, here our actually it is plus. This is nothing but x component, not x, z component of del cross E minus q ax by minus ay bx. So the final option is I q h hat. This is z component of the magnetic field vector, because already we know the B equal to del cross E. From the Maxwell equation you can realize what is the physical meaning of this one. So this is a Z component, the del cross A Z component B Z minus Q Ax By. The final answer is this one. You can check from the given question.